about 3.4 position. And we did talk about the z-score. And remember also, this is a distribution. We're going to use this a lot. It's a normal distribution. Normal means bell-shaped and symmetric. We don't know this yet. We'll talk about it. With the mean of 0 and a standard deviation of 1. How does this look? Like this. Here is the mean, which is 0. And we have, as we know, with the empirical rule, 68%, 95%, 99.7%. And the standard deviation is 1. Okay, so this definitely is -1, 1. And this is definitely -2, 2. And this is definitely -3, 3 for this distribution. It's called standard normal. Okay, so that is for a little bit later, but I want you to get used to it. That's why I'm going to write it a few times. Okay, the next one I would like to talk about is, so this is number 1, and number 2 for position, measure of position. Number 2 is percentiles. So for example, percentile 20, or any percentile, 15, or 79. What do they mean? So let's suppose we're interested in specifying the location of, in a distribution, symmetric distribution, let's say, of P20. So this is 0, and this is 100%. So 20 would be roughly somewhere here. Why? Because this will be 20%. So if I know that this is 20%, then I can determine the exact location or what the observation is in the data set. The same thing, let's say, with P79. So somewhere here I have P79. Why? Because it means that below, of course, we have 79%, and the rest of 21% are right here. Same with 20. 20% to the left, 80% to the right. Okay, so this is like, for example, for GRE or any tests, GMAT. There are all sorts of tests. And if you say, well, I am P80, I came in any of these tests as the 80th percentile. That's awesome. It means that 80% of all students who took, let's say, GRE at the same time with you had a score less than yours, and 20% of them had a score higher than yours, which is pretty good. If somebody says, I came in at P15, that's not that good, right? It's not good, because it means that only 15% of students who took that test came in lower than that score, whatever the score is. And the rest of 85% are higher. So that's not a good position. This is a good position. 79 is a good position. Okay, moving on to number 3, quartiles. So we have 4 quartiles. We have 100 percentiles, but only 4 quartiles. So if this is the distribution, so we only have Q2, we have Q1, and we have Q3. So you could say, what's this? Well, 1, 2, 3, 4. But the indication, the position, we have 3. Q1, Q2, Q3. But we have 4 quarters. Maybe I should say this, 4 quarters. And 3 quartiles. What does this represent? This is identical with P25. What does that mean? Well, this is 25% from 100%, and the rest is 75 above. This is the median, which we knew. We also call Q2. Of course, this is 50% and this is 50%. And what about Q3? Well, this is 75%. So this will be P75 and this is also P50. So 50 below, 50 above, 75, 75% above, 25% below, 75% below, 25% above. Any questions so far? Okay, I would like us to go ahead and enter this data in StatCrunch. I'm going to scan, not scan, I'm going to share my screen right now. Where are you guys? I see it. Okay. So where is my StatCrunch? So let's go to StatCrunch, open StatCrunch. So in variable, just write speed. I already entered my data so I can focus on you and not focus on entering my own data. So just enter speed. And I'm dictating now, just 14 entries, 14 observations, not a lot. Let me know when you're ready to enter the data with me.
Ready.
Perfect. Everyone?
Ready. Yes, I'm ready.
Okay. If you fall behind, stop me, please. 20, 24, 27, 28, 29, 30, 32, 33, 34, 36, 38, 39, 40, and 40. And make sure you have 14. Let's save the data. Click on Save, Data, Save. And here is how I saved it. You choose what you want, of course. Here's my data. And I called it speed. And I think I have it right here. So speed, and I have these entries. And now let's go to stat and summary statistics with columns. Summary stat, summary statistics with columns. Let me know if you fell behind. Anyone, please? Columns. And click on speed. And let's choose. I want to see the mean. No, I didn't mean that. Mean. Let's also compute the variance. Let's also compute the standard deviation. Definitely the mean. I don't need the standard error. I'll explain later what the standard error means. Okay, never mind. Range. I want the minimum, the maximum. Q1 and Q2 definitely. And then I'll explain this today. That's the next step in a minute. You don't need to determine it now. And that's it. And just press compute. Okay, let's enlarge this screen. Okay, so now the distribution has a Q1. I'm just going to write them here and then present them. So Q1 is 28. Q2, which is the median, is 32.5. Q3 is 38. And I'm going to write the mean as well, or X bar, as 32.14. Okay, I don't need anything else. So just the minimum, let's say, yeah, the minimum is 20 and the maximum is 40. Okay, I'm going to stop sharing. So let's talk about this. Okay, I'm on my page 2. Okay, so if I want to present, we're going to do this with the box plot today. So I'm going to start with identifying, okay, this is the minimum, which is 20, and this is the maximum, which is 40. So 30 should be somewhere here in the middle. And where is the mean? The mean is somewhere to the right. So I'm going to put the mean right here, x bar, as being 32.14. And Q1, roughly Q1. Q2, it's very close here. So I'm going to say Q2 is somewhere here. And then 38 somewhere here. So that's the Q3. How is this determined? How is this determined? Well, first of all, I have to arrange the data set in ascending order. So I am going to do it. So it appears, I already know that 20 is the minimum. I already listed them in ascending order. So that's the first step, ascending order. So I'm going to write them here, 24, 27, 28, 29, 30, 32, 33, 34, 36, 38, 39, 40, and 40. So we know that since we have 14, so lowercase n, sample size is 14, I know that the n plus 1, right, will be, so when I determine the median, which I already have, it's, what was it? Let me write it, 32.5. And Q3 was 38, and Q1 was 28, which we already have from StatCrunch. But how do I determine them? How do I determine Q1, Q2, Q3? Let's say I don't have StatCrunch. I don't have a calculator. I just want you to know you're not going to be asked to do this by hand, but I want to explain how it's done. So we see we have to look, since it's 14, right? So I have to look at the 7th and the 8th observation and determine the Q2, right? So 2, 4, 6, so 6, 2, 4, 6. So these are the middle two observations. 6 to the left, 6 to the right. These are the middle two. If I had an odd number, then the median would have been one of the existing observations, but I have an even number of observations. So then X bar will definitely, Q2 will definitely be 32 plus 33 divided by 2. And that's how we get Q2, the 32.5. Now, how do I determine the other ones? How do I determine Q1 and Q2? I will repeat the same steps. I will repeat and look at these observations. So now I have 2, 4, 6, 7 observations. Then that's how I get the middle one to be Q1. Whenever we have an odd number of observations, the middle one, in ascending order, of course, the exact middle one will be the median of this data set. And of course, how did we get 38? The same thing. From here, I have 7 observations. The middle one is 38, so that will be Q3. That's how these numbers are obtained. What do they mean again? Well, it means that Q1 below 28, we have 25% of the observations. Between Q1 and Q3, very important, we have the middle 50% of the observations. And of course, between Q3 and the maximum, we have 25% of the observations. We also know that 50% are here below Q2, 50% and 50% above. But what I would like to emphasize again is that between Q1 and Q3, we also have 50%. So this will be something very important. It will be called, and this is number 3. That's why I wanted to continue with this. IQR. It's called the interquartile range. So the difference between Q3, which is Q3 minus Q1, the interquartile range. And this is the middle, as I already mentioned there, middle 50% of the data set of data. Okay. So in our example, Q3, we see the interquartile range will be Q3 minus Q1, Q3 38, Q1 28, the interquartile range is 10. So between these two observations, which the range is 10, we will have 50% of the observations. And we can determine them and we can look and find of those 50 observations. Okay, another very important item here is number 4, which deals with outliers. So here's a situation with an outlier. So let's suppose I plot the observations. And I get everything in a cloud like this. But then I get one here, far out, or maybe I get one here, which are normally signified with stars like that. This is an outlier. Something unusual, far out, positive on the higher end or far out at the lower end. How are these outliers determined in the data set? Okay. How do we find those? To find outliers, okay, we have to, number 1, find the interquartile range. Number 2, we have to find something called upper and lower fence. So let's stop for a second and see if you have any questions for me.